In this example, we have just a little bit more stuff on both sides, but we still don't have the linear term, so we can still solve by taking square roots. So we're going to go into that, and I'm actually debating about solving this one by factoring, but showing it in a different way, because the last one I did do where I changed it into a difference of squares, but I'm wondering if I might be able to set this one up and still solve by a C method with grouping. We'll see. I'm kind of like thinking ahead about how it's going to work out, so let's find out. Ready? Ready. Now we want to get x squared to the other side for sure. Typically, your initial goal is going to be to get your polynomial equation, and that's what a quadratic is, equal to 0 when you're solving. This right here becomes 2x squared. Adding and subtracting x squared is like bananas. 3 bananas minus 1 banana, 2 bananas. I could write +1 and this -1, but then I have another step of bringing the 1. Well, let's just bring it over right now. I'm not trying to be a rock star and skipping steps, and I do math all day, every day for as long as you've been alive. So you should probably write the steps down too. Just saying. When things go away in addition and subtraction and become nothing or 0, we are allowed to say that they cancel. When you cross something out from a numerator and denominator, that is not cancel. That is to simplify or to reduce. I know I'm annoying. I say it all the time, remind you constantly, but I want you to sound smart, you know? 1 + 1 is 2. Now, if I was in the mindset of solving by factoring, I had just done a dozen examples and I was solving all of them by factoring, no problem. Well, then I might dive right into this one and attempt to factor it, right? Which is even a thing like, say, on the SAT, you might do a question like number 9 is set up in such a way that you're have a bit of a flow going. Then number 10 is sort of a similar style problem. And then when you get to number 11, maybe that was almost setting you up to try that other thing, whether intentional or not. And you're gonna start and veer off in the wrong direction, and you're gonna have to kind of like regroup and think about, well, what is the best approach for this problem, right? So let's just say we had our rhythm going and we were solving by factoring. What factoring technique do I always beg everyone to do first? To take out a greatest common factor. And I know you know that, but you never do that. Why don't you do that? Do you like making mistakes? Do you like messing up at the end of a problem? No, right? So like, listen to me, okay? This is my job. So we're going to take out this greatest common factor. Since the greatest, and I'm underlining it to show that I'm dividing something out, a 2, the greatest common factor, and then I'm going to also simultaneously multiply out front by that. That's like multiplying by 2 over 2, which is 1, the multiplicative identity, which we are allowed to do. We do that when we rationalize a denominator. I like to show this because if you are in calculus and you are, say, doing something called antiderivatives or finding the integral, there are going to be times where you're going to have these awkward numbers that you want to either have in front or to take out, and you're factoring out this awkward fraction, and it's not a GCF so much as just a number you need to factor out. Well, if whatever it is you're taking out, you're undistributing, right? So you're technically dividing by it, but you can't just randomly divide, so you also multiply at the same time. Now I know, since this is equal to 0, really I could just divide both sides by 2 and throw it away. Why didn't I do that? To show you the technique is one reason, and the other reason is if the greatest common factor has an x in it, right? A variable of some sort, or a sine theta. You can't divide both sides by sine theta or x. You can't divide both sides by a variable because you will throw an answer away. If this video is not too long, I'll show you what I mean in a very classic example, very SAT-ish, I would say, but just classic example in just a few minutes. So let's see. Now, what do I have next? I have 2, And this will be x squared plus 1, right? Equals 0. Now, 2, I have a couple options. I could divide both sides by the 2 now because there is no x with it and get rid of it. Or if you were trying zero product property and you set 2 equal to 0, you might be like, that's not true. You're right. It isn't true. It's false. Just cross it out. But if it was 2x, if it were 2x, the variable equals 0, why are we so weird? How do we get the x alone, guys? How? Please tell me. Please tell me you know how. You divide by 2, right? And what's 0 divided by 2? Jeez Louise, it's 0, not 2, not 1, not undefined. What the heckers are we talking about over here, right? So what do we need to remember? 0 over a number like 1, that is okay. And that is 0. But what about like 1, say, just using 1 as my example, over 0? No. All right, that, my friend, is undefined. Please remember that. So 0 is over 2 is just 0, okay? And then 0 over 0, that kind of looks like a chubby cartoon division sign that probably means we can reduce and divide something out from our numerator and denominator, but we'll cross that bridge when we get to it as well. So that 2 essentially is gone, gives us nothing, right? And this was not the case. I was just showing us this. My tangents, I'm so sorry, but I just want to fill your brains. Now here, I was debating how to solve this guy, but I don't think this might, I'm just going to solve by taking square roots because I'd rather have the time to show you that other scenario, okay? So x squared is equal to -1, x, square root of x squared, right? That becomes x, equals plus minus the square root of -1, which is plus minus just I. That's it, okay? Plus minus I. Ooh, sorry. And that's all there is. And we're done, okay? Finito. What was that side example I wanted to tell you about? Well, say you had something like this, x squared equals x, and the example was like solve, right? If you, I'm dying inside. So anyone who's just like fast forwarding and copying down what's on the screen and not listening, you're writing down some real trash right now. This reduces to x, sure. This is 1, sure. But you threw an answer away. You can't divide by a variable for so many reasons. Biggest thing that we can say is a variable can vary, hence the name variable. It's not a constant that remains constant, right? And if a variable can vary, well, what if it equals 0? You can't have 0 in the denominator. We just said, no, right? So really, would I do this? No way. So I'm not even going to cross it out. So anyone who fast forwarded and just copy what's on screen, that's what you get for not listening to instruction. What do you do if you had to solve this? We get it equal to 0. So subtract x from both sides. And then what do? We factor. And what factoring technique do we always try first? Greatest common factor. Wow, it's like all the rules and ideas and suggestions that I've been giving you guys are like really good or something. So what am I going to factor out? An x. But if I divide that out here, I'm going to multiply it out front. Do we always show all this? Absolutely not. So what do I get in the next line? X, pretzel. We got x minus 1 equals 0. Then we bust out 0 product property. X equal to 0. X minus 1 equals 0. And x equals 1. So we get 2 answers. I've been stressing the fact that when you're solving a polynomial equation, now that we've introduced imaginary or complex numbers, the degree of the polynomial equation tells you how many answers you will have at the end of solving, including both your real and your imaginary answers, right? And if an answer is repeated in the sense that it has a multiplicity, say, of 2 or 3 or 4, each of those counts as separate answers. So if it was like from a parenthesis with a 3 cube on the outside, well, if you got the answer x equals 2 from that, well, you have 2, 2, 2. You have 2 3 times technically, all right? So that was just a side example that I spoke about before. We're not allowed to divide by x. Please never divide by a variable or something with a variable in it. And I hope we realize that this is going to put you on the naughty list. This puts you on the nice list. And sorry I talk so much, but I just want you to have the information. All right, so I don't know. Oh, I have one more, I think, for this set of examples, and that'll be the end of this playlist for now. And who knows, look at it. Maybe there's like 100 new videos by the time you see it. And yeah, sayonara.